All right, so this is not a journal before I start. So this here was, we did a bell work in class, and then we actually did problems on the homework packet because this lesson here is pretty short. So it doesn't really need official notes. So we're going to go over some warm-up problems to help us get into the flow of things. So these problems here, you're solving for x, meaning eventually you have to get x by itself. Notice how there is a square here. So to get rid of a square, or the power of 2, you actually have to take a square root. Square roots actually cancel out the 2 and the root, leaving just the x behind. But anything you do to one side, you have to do the other. So I have to square root the other side. So like I said before, x comes down because the 2 and the root cancel with each other. The square root of 25 is 5. Now, here's the thing I want to mention. The answer is not just positive 5. Turns out it is also equal to negative 5. So I'm going to put a comma there to add my extra number. The reason why negative 5 also works is because if you were to plug negative 5 back in and square it, well, that's just saying negative 5 times negative 5, which is, well, 5 times 5 is 25, and 2 negatives make a positive number. So this would also give you positive 25. So negative 5s also work. So when you take a square root, you get a positive number and you get a negative number. I also want to mention you might get tired of writing, negative 5 and positive 5, so you can also write this shorthand. So you can also write this as x equals positive and negative 5. This is the shorthand way of saying the same thing here. That's a positive sign, that's a negative sign, so you can say positive and negative 5. So we're going to solve out the rest of this here, but I also want to mention, do you remember when I said in class, anything to a power tells you how many solutions you have? So if this is x squared, you should have 2 solutions. Notice how we have 2 x values here. Well, I should have 2 x values when I solve this out. And so to try to get this x by itself, I got to cancel out that 2 or that square, so I'm going to square root it, and that cancels out the 2, bringing down the x. The square root of 17. Now, is 17 a perfect square? No, 17 doesn't break down into anything. So in this case, 17 is not a perfect square, and we can keep it under the root. So if it's not a perfect square, keep it under the root. I'm going to show you exceptions to this, but for now, just know that. When you take the square root of 17, it's not just positive 17, it also can be negative. So I'm going to put a plus and a minus sign in front of it to represent that it can be both positive and negative. And so that's my answer. All right, the last one here. So this one is also being squared, so I need to get rid of the square by taking the square root of both sides. And so those 2 and the root cancel, x drops down. The square root of 8. Now, 8 is not a perfect square. However, 8 does break down into things like 17. The only thing that multiplies to give you 17 is 1 and 17. So back in elementary school, or I think actually more in middle school, you learn how to make a factor tree, right? And so factor trees are great for finding, simplifying square roots. So I can leave my answer as the square root of positive 8 plus or minus, but this is actually not the most simplified form, okay? So I'm going to show you what would be a better answer. So let's go find that. So just to break down 8, the factor tree for 8 would be maybe starting with 2. 2 times 4 gives me 8. 2 here is what we call a prime number. Prime numbers are any numbers that cannot be broken down other than multiplying itself by 1. So the only way to get 2 is 2 times 1. And so 2 here is considered a prime number. But 4 isn't, because 4 can break down to 2 times 2. And then it looks like my prime numbers are 2, 2, and 2. So the 2's are all what I have left. So factor trees, you break it down to its prime numbers, and then square roots actually take identical pairs. So in this case, I have an identical pair of, so I'm going to take my pairs. So I have a pair of 2's. So that means the 2 comes out. But anything left over, like this extra 2, doesn't have a pair, or doesn't have another 2 to pair it with. So that 2 goes back inside the root. So it looks like the square root of 8 is actually 2 square root of 2. Keep in mind it's a positive and a negative in front. The reason why you want to take out pairs, let me give you guys a simpler example. Like the square root of 25, when you break 25 down as a factor tree, 5 times 5 gives you 25, and 5s are prime numbers, so I can't break this down anymore. So like I said, square roots take pairs. There are a pair of 5, so that 5 can come outside the root. And so there are no more numbers that need to be paired up. So it's only the 5 that comes out. There's nothing that needs to go back inside the root. So square roots identify the pairs that come out of the root. All right, now that we've gotten warmed up here, let's do some homework problems from Packet 5, page 1. So here I have some problems from Packet 5, page 1. I'm going to do problems 2 and 4 first. So to do this problem, I need to solve for x. So to solve for x, I need to move over some things first. Like in this case, to solve for this x, I need to move over this 289 first. So I have to add, since it's a minus, add 289 to both sides. So typically to solve for x, you want to move the thing that's further away first. So in this case, the 289 is further away from the x. And then adding 289 to the other side, it just makes it 289. Okay, now we learned that to get rid of a square, I have to take the square root of both sides. So I'm going to go ahead and do that. The 2 and the square root cancel. X comes down. The square root of 289 is plus or minus. Square root of 89 is 17. So in this case here, 289 is a perfect square, but I need to put a positive and a negative sign to make sure that I say that it's not only positive. And that's my answer. All right, let's try another one here. So to try to solve for x here, I need to get the x by itself. So do I move over the 2 first, the 10, or the square? Well, in this case, I need to move the thing that's further away. So this 2 is right next to the x, right? So I don't want to move over the 2 first. I want to move over this minus 10. It's a little bit further. So I have to add 10 to both sides. That cancels. 2x squared drops down. 10 drops down, because 0 plus 10 is 10. If I divide by 2 to get rid of this 2, so you want to get rid of the coefficient first. And so now I have x squared equals 10 divided by 2 gives me 5. And so to get rid of this square, I have to take the square root. Because anytime I want to get rid of a square, I have to square root it. So here I go. X drops down now without a power on it. And so the square root of 5 is not a perfect square. And also 5 is a prime number. It doesn't break down into anything. So because it's not a perfect square, I'm going to keep it under the root. And the square root of 5 is, well, positive and negative square root of 5. And that's it. Okay, so let's try out some more. I'm going to do 3 more problems with you from the homework. So this one's number 5 from the homework, and it has some fractions going on here. So first, I'm going to try to get this x squared by itself. So I need to remove this 4 first by subtracting. So if I subtract by 4, that cancels. And then the 1/3 x squared comes down. 8 minus 4 is positive 4. Now I have to get rid of this 1/3. So to get rid of a fraction, I can multiply by the reciprocal. The reciprocal of 1/3, reciprocal just means to flip. So if I flip this, this would be 3/1, and I multiply, and that actually allows me to cancel out the 1/3. And so x squared comes down, but anything I do to one side, I have to multiply the other side by 3/1 as well. And so if I were to do that, I can put maybe the 4/1 and then multiply this straight across. So 4 times 3 gives me 12. 1 times 1 gives me 1. So this is really x squared equals 12. Yeah. And so looking at this here, I have to get rid of this square here, so I'm going to take the square root. So the 2 and the root cancel, bringing down x. And the square root of 12, 12 is not a perfect square, but I can factor tree it. So 4 times 3 gives me 12. 3 is a prime number, but 4 isn't. 4 can be broken down as 2 and 2, and then I have a pair of 2s, so that comes out of the root. But I have a leftover 3 here, so that means the 3 goes back inside the root. So in this case, this is really 2 square root of 3, but it is a positive and a negative, because square roots, you always have a positive and negative sign. And that's it. That's my x value. All right, let's do 2 more together. So this problem here, number 8, has a number in front of this parentheses and then has x squared on the other side. So first things first, what I notice is that this 3 is in front of this parentheses, and this parentheses doesn't have an exponent in front of it. So I can go ahead and distribute that 3 inside. So because there's no exponents in the way of this parentheses, I can distribute, and that would make me have 3x squared, 3 times 4 gives me negative 12. I'm going to bring down the right-hand side. And so when I'm looking at this problem, like, I need to get x by itself, so maybe I can move all my x's to one side and all my numbers to the other side. So I'm going to try to move this 2x squared to the other side by subtracting 2x squared off. That cancels. Negative 1 drops down, negative 12 drops down. 3x squared minus 2x squared gives me 1x squared, or just x squared. And then to get this x squared by itself, maybe I can move this 12 over to the other side by adding 12. And then x squared drops down. Negative 1 plus 12 gives me 11. And so to get rid of this square, I square root it. And so x comes down, square root of 11. 11 is not a perfect square, and also 11 is a prime number. Nothing factors from 11. So in this case, I have to keep it under the root, and I need a plus or minus in front of it. All right, so that's it for number 8. Number 9 here. This one's a little bit trickier. So if you look at 9, as much as I like to distribute this 2, I can't. And the reason why I can't is there's the square and exponent in the way. So I can't distribute this because order of operation says you have to do exponents first and then do division. Sorry, not division, multiplication. So this 2 is multiplying this parentheses, but it can't multiply because of the exponents. So first off, I want to get this x by itself, but I need to take off each layer one by one. So I like you guys to think of this like an onion and figure out what is the outer layer, right? When you're peeling an onion, you have to peel the outer layer first, and then you get to the core. And our core here is the x. In the end, I want to get x by itself. So the outer piece here, if you take a look, so x is here, the next thing that's next to it is a negative 1. The next thing that's next to it is the square, and then the furthest thing out is actually this 2. So I have to take care of this 2 first by removing it. To undo this 2 is multiplying the parentheses, so to undo it, I have to divide. That allows me to cancel. So then x minus 1 squared drops down, and then 8 divided by 2 is 4. So to get rid of this square, I have to square root it. And actually, let me pause there. Let me actually go back here for a moment. So I went a little fast there. A lot of people, when they see the square and parentheses, they will distribute this 2 inside the parentheses. And I'm going to tell you, please do not ever distribute this 2 inside the parentheses. Exponents don't work that way when it comes to parentheses. Okay? And I will show you how to deal with things that are squared when you are having to deal with it with parentheses. But for now, I'm going to show you that anytime you see a square, you square root it to get rid of it. So I got to square root both sides to get rid of the 2 and the root. So then the x minus 1 drops down. Notice that the parentheses was only there for this exponent. Once you cancel it out, you don't need those parentheses, so I just drop down whatever's inside the parentheses. The square root of 4 is a nice number. It's 2, but it's plus or minus 2. So it's plus and minus 2. From here, I still need to remove this 1 by adding it over. But before I do that, because I notice that this is plus and minus 2, I can break this up into 2 equations to make this easier for me to solve for x, since I'm going to get 2 x values anyways. So one of the equations is going to be a positive 2, and the other equation is going to be a negative 2. So if I were to try to solve for x, I need to remove the 1 by adding it to both sides. So I'm going to do that here. And so x is equal to 2 plus 1 is 3. And if I add 1 to this side, x is equal to negative 2 plus 1 is negative 1. And so x is equal to 3, x is equal to negative 1. So when you have a plus and minus sign and you're not done solving, just split it up into 2 equations and keep proceeding with solving both of the equations out. And that's it for this lesson. I hope that helps you out with your homework. Try out the other ones now.